Hello everybody. So this week we're going to be talking about light, shade, and shadow and all of the things that go into that. So we're moving past line and we're getting into form and value and trying to create that sense of 3D by using form. And to do that, we need to talk about light. And we're going to talk about the scientific nature of light, how it works, and how you can use it to calculate light using perspective to actually figure out the shape of light. And we're going to get into values and shading and things like that. So the first thing you got to understand is that most people have a tendency to kind of guess what their shadows look like. You know, they're doing the drawing, they have their object, and we're going to put a shadow under this. So we're just going to guess that this is kind of what our shadow is going to look like. Now, it's one of those things that you can guess and kind of get away with it, but you really need to understand that shadows are complex and they're actually based off of perspective. So it's really to understand perspective so that you can start figuring out how your shadows work and why they work that way. And it's really based off of perspective and your light source. So how we view the light source hitting the object and what that shadow or lack of light looks like in perspective. So these are things that we're really going to need to understand. So we're going to be going all into that in this lesson here. Okay, so we have our light, shade, and our shadow. Now, the first thing we need to understand is orientation of light. Basically, your orientation of light will determine so many things. So you've got to think about where your light is coming from in a 3D space in relation to your object and in relation to you. So let's look at this from a top-down view. I'm going to do top, down, and I'm going to actually put orientation so you know what we're doing here. And so we have our top-down view. So that means we're going to have our cube, and we're looking down at it. And then let's say this is where we are standing. This is our eyeball, and we're looking at this cube in front of us here. So you got to think about, where is our light source? Where is it coming from? And let's say it's our sun. So we need to figure out where it is in relation to us. Is the sun in front of us? Is the sun off to the side? Or the other side? Or is it behind us? And all of these factors, all these different options are going to make a difference, because where the sun is going to affect where the shadow is going to be. So it will what we need to figure out is where our sun is. And this is going to help figure out where our shadow will be. So if we were to look at this sun here, this sun would create a shadow that would be in this direction. If this was our sun here, this would create a shadow in this direction. And this one here would create a shadow in this direction. So knowing where that sun is, or where that light source is going to affect where your shadow is going to be. So first of all, knowing where your light source is coming from will help determine the direction of your shadow. Okay, now if we were to look at this from a side view, so we got our cube here, sitting in space, and then here we are, here's our eyeball looking at it from the side. So the next thing we need to figure out is basically the height of our light, where it's coming from in this side view. Let's say this is our sun again, and it's going to be right here at high noon. This is the middle of the day. The sun is highest in the sky, directly above it. Or is it more like late afternoon and the sun's like starting to set, it's kind of part way down here? Or is the sun setting and it's all the way down here? And what this will affect is the length of our shadow. So if the sun is directly above it and it's beaming right down on our object, our shadow is going to be right beneath it. It's going to be a little tiny shadow right beneath it. If the sun's lower down in the sky, what it's going to do is cause a shadow that's a little bit more like this. So it's going to get a little bit longer. But then we got this sun all the way down here. This is going to create a really long shadow. So the height of our sun or our light in relation to our object will affect the length of our shadow. So that's going to be really important to know this here. Okay, the next thing I want to talk about is how light works. So we're going to get a little scientific here. I want to think about, what light is, because knowing what it is and how it works will affect what happens. So, scientifically, light is essentially a bunch of photons. So here's our little photon balls, these little blobs. This is our light, and they are moving at a rapid pace together. And these photons together is what creates our rays of light, or a beam of light. And this we call ray of light. So this is kind of what's making up our light itself. So the next thing I want to think about is the sun, and how does the sun work? Because this is going to be important. So this is our sun in our solar system, and this over here is Earth. So that little dot, this is Earth. And this is our sun. And the first thing you got to realize is that we are very, 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 very far away from the sun. So that's going to affect things. And essentially what's happening is this is our sun. It's a ball of light that is radiating light out of it. So that means that there is rays of light projecting out in all directions, all the way around. And there's basically an infinite number of rays. There's so many, I just keep drawing them forever, but they're all going out in every single direction. And if you think about this, if you're ever outside at night looking up at the stars, we all should know that those stars we're seeing are actually suns from galaxies that are billions and billions of miles, or whatever you call them, light years, there you go, light years away. So they are so far away, but that light is traveling all the way from that far, not only in space, but in time. A lot of those suns aren't even around anymore. They've already died, but that light is still traveling towards us. That's how strong this light is that comes from our sun and from other suns. So the important thing is that when the sun hits us, because we are so far away, even though all these lights are coming out at different angles, we are so far away from the sun that when it gets to us, it looks like all these rays of light are coming in parallel. We would think that they're going to look like this, because that's what our little drawing was. All the rays look like they're coming out at angles. But we are so far away that by the time it gets to us, they look like they're parallel. So this is super important that we understand that whenever we're drawing objects that are coming from sunlight, the rays of light that are creating them are parallel to each other, or at least appear parallel to each other. So super important. Now, the other scenario we have when it comes to lighting is artificial light, or as we can call it, a light bulb. This is basically the other situation you have. And a light bulb works like a sun. The light beams are radiating out from it, coming out in all directions. But compared to a sun, a light bulb is a lot closer to us. So because it's so close to us that these light beams, these rays of light, they're still gonna look like they're coming out at angles. And that's gonna affect the shape of the shadow. You know, if the light's going straight or if the light's going out at angles like that, it's gonna affect how the shadow will look, and it will also affect our perspective when we get to that. So this is really, really important for you to understand, you know, how the kind of science of this works here. And the other thing I do want to talk about, our little science lesson. Let's say we have our box here and it's sitting on the ground. And we have our light coming down at it like this from an angle. And right now, it doesn't matter whether or not it's sunlight or it's an artificial light, because this is going to work the same. But what happens is our light comes down, and when light hits an object, it actually bounces off that object. And then it's going to hit again and bounce off again. So this is what light is doing, and the stronger the light source, you know, the more it's going to bounce around. So it's really important to know that this light is actually bouncing. It's not static. It doesn't just hit an object and stop. It will move around. And so what's happening is it comes down, it hits our object, and not all of it is going to bounce. A little bit will actually be absorbed into our object, and then the rest of it will bounce. And then a little of it will be absorbed, and the rest of it will bounce. And that means that it's getting weaker and weaker each time. So let's say this light was 100% here when it hit our object, a little got absorbed and it bounced off. Let's say that it's probably, let's say maybe 75%. And then it bounces again. Now it's at 50%. So the more times your light bounces, the weaker it's going to get. And this is actually, you know, how we get our atmosphere, or this ambient light that we have in our atmosphere. So if you think about it, the sunbeams are coming down, it hits our atmosphere, and the atmosphere is actually, you know, working as kind of a way of bouncing off light. It is hitting our atmosphere, and light just starts bouncing off everywhere. And this is what creates the look of our sky being blue. And this light that is bouncing off, this is what illuminates our Earth here. And if you're outside looking at the shadows, you're looking at the shadows underneath something, you notice the shadows aren't super dark. They're not pitch black. There actually is a little bit of light in the shadows, and that's because there's so much ambient light coming from outside that it is bouncing off other things and lightening the shadows a little bit. What is also happening, because this light is bouncing off, you know, it's bouncing off the sky, and it's also going to be adding some blue to all our shadows. And this is when we're outside. Pay attention, start looking at shadows. Shadows outside have a blue tint to them, and that's because it is reflecting the color of the sky that's coming from the light. That's your little fun fact for today. But back to this here. So this light here that's bounced off, we call this indirect light. Now this, just to compare, this is direct light. If we have light that is coming right out from an object, it's not bounced off anything, it's called direct light. If it is bouncing off of something, it's now called indirect, because it's been averted. It's no longer straight from its original source. This is also called reflected light, which I kind of think is the best term for it. It's the most explaining of the terms, because it is bouncing off and will cause reflections into everything. It's reflecting off the object. And then it can also be called ambient light. And that's when, you know, think of our atmosphere, think of outside. There's so much ambient light outside because it's bouncing off of everything out there. So that's really important to know. We're going to explain this a little bit more soon. So next up, I want to talk about some definitions here. Now, I drew a couple little examples because I want to break down, you know, all the little terms that we're going to be using here, and some we may not use, but that are kind of good to know. So let's look here first at our cube, and we have a light source. Let's say we have the sun. This is our sun all the way over here, and it has light that's coming down this way, so it's kind of coming down from behind it. And the first thing that's happening is it's, you know, basically hitting our object here, and then we have the shadow on this whole back side of our cube and behind it. So this area on the top of our cube here, this area that is getting direct light on it, this is called light. This is the light side of our object, right? And that kind of makes sense. It's the area that's getting the light. Now, if we move down here, these two sides, they're not getting hit by the light because they're on the back side of it. These two sides, we're going to call shade. You know, because they're in the shade, you can think of that, because they have that bit of darkness to them because they're not getting that direct light. Now, to be a little bit more specific, these two sides will have different names. You notice this side is a little bit darker than this side, and it's because it's farther away from the light source, because this one's kind of on that side there. Maybe it's getting a little bit of ambient light coming around, and this one's farther away. So this one that's farther away, that's darker, we would call this deep shade. And this one here that's got a little bit lightness to it, we're going to call it half shade. Now, it's really not super necessary that you know these two terms, the deep shade and the half shade. It's just one of those pieces of information that's kind of nice to know. It's just more important to know that this side is called the shade side of your object. And then down here, we have our shadow. But it's also called the cast shadow. And it's called that because the light is hitting our object and a shadow is being cast down from this object. It is the object that is casting it onto the ground here. So you can kind of use those terms interchangeably. Okay, moving on. Now I have a sphere. We're getting into a slightly more complicated object now. And things are going to be more difficult. There's going to be more things happening in this. We don't just have flat sides. We have rounded sides. And how the light goes around those sides is going to change what we call them. So, first important thing to know. You can see, hopefully you can see, I have this area of my lightest light right here. Now we're going to say my sun is over here. And this is called our highlight. The highlight is the brightest bright on your object. And the one thing you'll notice, even with my sun here, even if my sun was partially behind it, your highlight is never going to be all the way on the edge of your object. It's always in it, just a little bit. And that's what gives it that form of 3D, because it's receding backwards. And it'll never be on the edge. The only time it appears like light will be on your edge is if your light source is all the way behind your object. Let's say it was right here behind it. That's how you get a situation called rim lighting, where there's light coming all the way around the edges. Kind of like you picture someone standing in front of a moon, you get just that little edge of light. That's the only time your light will be all the way on the edge. Every other time, it's going to be inside your object just a little bit. So that is called our highlight. Now, there's kind of two basic areas to our sphere now after that, and we'll break it down further. So there is the rest of the light area, and then there's the rest of basically the shadow area. So let's talk about this light area first. So this is still like this side. It's still hitting light. Light is still hitting on it, but it's not as bright as our highlight. And what our highlight actually is, it's actually a reflection of our light. So it will mimic usually the shape of your light source. It will also mimic color of it. So, depending if you have on a warm or a cool light, like a bluish light or a yellow light, it actually can reflect the color too. But usually this is like pure white, and that's basically the only pure white we ever see. Everything around it is going to be a little bit darker, but this is still in light. And this we call the half light. And we call it this, just like this area over here was a half shade, but this is in the light end, so we call it half light. Okay, then we get to our shadow area. Now this whole shadow area we're going to call form shadow. So that's the entire shadow area. And you'll see that there are different values that are happening within it. And this is really important. If you're not really paying attention, you're just kind of drawing shadows the way you think they might be, it's very easy just to draw one solid shadow, the same level of value from top to bottom. But it's really important to know that that's not how it works. There are lighter areas of shadow and darker areas of shadow, and understanding how this works will really improve your drawing and really improve that look of 3-dimension you're gonna get. So when you see it, our shadow area, you'll notice that the darkest part of it is actually kind of in the middle here. It's not what we would think, which would be on the bottom. And I'll explain why that's happening in a second. But really where it is at that point where light transitions to shadow. At that very spot is where we're going to see what we call this core shadow. That is the darkest part. And this will be in everything. Everything around you, anything that the light is hitting it, there's going to be an area called a core shadow, and that is the darkest area of the shadow. And it's really important when we get into things like arms and legs and even face, this part where light transitions to shadow, where the two sides meet in the middle, is where the core shadow is. So then why is it lighter here? You would expect it's farther away from the light. That means it would mean it's darker. But what's actually happening is reflected light. And that's where that comes into effect, what we were talking about earlier. What's happening is the sun is bouncing around, that light is coming down, bouncing off of everything, and it is bouncing off the table back up here, and it is lighting up this edge here. It is reflective light, and that is so important to know, and it will make your drawings look so much more realistic when you start to see this reflected light that is happening. That lightest area of your shadow. The core shadow can also be called the terminator. But core shadow is really the common phrase that we use. And then this is the reflective light. So really pay attention. Start looking at objects in everyday situations, whether it's with the sun, whether it's with artificial light, you will have this core shadow, the darkest part of your form. Okay, let's move on to the actual shadow that we have going on here. Just like our object, it's important to know that there are different sections and different values that are happening within this. So the big main parts, there's this one here. This is called our umbra. And then this area here, it's kind of the big part of it, is called our penumbra. And then there's this outer area here. This is called our anteumbra. Now, let's put lines here. Now, these names are really not important. You will almost never hear these three terms referred to, but just for your peace of mind, that's what they are called. And the three of them together, this whole thing is, remember, called our cast shadow. So I'll just write that in. That's the whole thing. Okay, so then let's get to our umbra. The umbra is essentially the darkest area of our shadow. And there's actually a couple parts to it. The first thing you'll notice, the darkest area I have here is right where these two forms meet. And this is really important to know, because what's happening is these two forms, they're so close to each other that it is so hard for light to get in and under there. So that's where you're really going to get your darkest part right underneath. And that is called the ambient occlusion. Once again, not an important name to know, but it is important to understand what is happening, that this is going to be the darkest part right here. And then it's going to get slightly lighter within this umbra. You're going to have that dark part there in this area that's slightly lighter. And what's happening here is that you're actually having reflective light. Again, it's reflecting off the ground to the ball, to here, over and over, and then it's just going on and on. So this is slightly lighter than what's happening here because of that reflective light, and this is all part of the umbra. The next part is the penumbra, and that's the biggest part of the shadow, and it's going to get lighter as it gets farther away from the object. And then the last thing is the anteumbra, and that's just essentially the outer edge. And this, you'd wonder why it has a name for like just the edge. But the edge can change based on how close or far away your light source is. So if we had a light source that was like right here, super close to our ball, the anteumbra would have a really, really sharp edge. It'd be crisp and sharp. But if that light was far away, like super, super far away here, that edge would be a really soft and just fade out into nothing. So thinking about how close or far your light source is will affect this edge, and it's one of those kind of key indicators. Even if we can't see our light source, we will understand subconsciously how close or far away it is by this edge, by how soft or hard that edge is all the way around. Okay, so that kind of covers the basics here for light, our terms, and in our little science lesson. So I really want you to start paying attention to light around you and shadow around you. Look at shadows. If you're sitting in your kitchen table eating dinner, look at the shadows underneath the objects. Start looking at the light itself. How strong is the light? How close is it? What angle is it from your object? And the kind of shadows it's creating. And then look closely at those shadows. Try to find that core shadow and look for that reflective light. And find that darkest area, the ambient occlusion underneath, and your highlight, all these little things. Just start looking at it, and once you start to see it, it's really going to help you improve your objects and make things look so much more realistic. Okay?